We are in a week for mock examinations for those that are in Senior 4 and those who are in Senior 6. In our today's video, I will be taking you through the mock from Jinja Joint Examinations Board. And this will be Principal Mathematics, Paper 1, 2026. For those that are here for the first time, TV is my name. And in our today's video, I will be taking you through all the required responses for this paper, that is Principal Mathematics, Paper 1, from Jinja Joint Examinations Board. And please, if you are here for the first time, I would like to inform you that we have already looked at very many mock examinations from different mock bodies. So far, we have looked at Kamasa Joint Mock. It is here. You can go through that video. We have also looked at the Principal Mathematics, that is Paper 2 mock exam, Chieteka mock exam, Kamasa pre-mock. We have Chieteka Paper 1 and Paper 2, we have gone through that. And then we have A-Level 2026 mock Paper 1, every item solved from TV Math Hub. We have a lot of videos that will be helping you during your revision. So please go to TV Math Hub, check for any video that you are interested in, and try to make sure that you follow along. So in our today's session, I will be taking you through Principal Mathematics Paper 1. All the items will be solved. So please make sure you watch this video up to the end. And of course, don't forget to give us a like or to share this video to all your friends. So before we come to the items within this paper, I would like to take you through Paper 2 first. So this was Paper 2. This was the Principal Mathematics Paper 2. And what we shall be looking at will be Paper 1. So this was Paper 2. So I will take you through this paper very fast, so you can as well get to know what was briefly talked about within this paper. So in case you are interested in the responses to this paper, tell me in the comment section, or if you have any other mock of your interest that you would like us to discuss on TV Math Hub, place it in the comment section. I will be going through all the comments, identifying which mock body the students are interested in, and that will be the exam that we shall specifically go through in our next video. So don't forget to comment, don't forget to put the paper of your interest that you would like us to go through. So this is paper 2. This is paper 2. So simply take the screenshot and try these items. In case you find any challenges, always get reach to me, and we shall always work upon that. So this is paper 2. So I should as well remind all of you that we already have the video regarding all the mathematics papers from different mock bodies that have been so far done. So in case you are interested in that video, also go to TV Math Hub. That video is there. So the video is here. That is all 2026 mock exams explained, all the mock bodies that have so far been done. We have already uploaded the video about that and how best you can get all the documents. That is the papers that have been done. All these papers have been uploaded to my website, that is TV Math Hub. So simply go to your Google and simply place there TV Math Hub online tutoring. If you are interested in those papers, simply come to TV Math Hub online tutoring. Put it there, TV Math Hub online tutoring. So search for that and it will bring you to this. That is TV Math Hub Premier Online Mathematics Tutor. So come to this website here and now look for the papers. There are very many papers. So simply go to resources and from there you will be able to meet some of these papers. So we have these papers here. You can download them. A-Level Mock Papers 2026. All these papers are here. So these are the papers that have so far been done specifically for mathematics. So all these papers have been done. So if you want to check for any paper, please come to my website and you will be able to get some of these papers. So I will also attach the link in the description so you can go through those papers. So here is item number 5. Please make sure you pause the video and then take the item, or else go to my website and download these papers. So that is all about paper 2, and without wasting time, we shall be coming to paper 1. That is the paper of our interest in our today's video. So let us look at this paper here. It was taking 3 hours. It is important to, of course, look at the instructions. So the instructions are clear. We have 2 sections, that is A and B, and this paper has got 5 examination items. Section A is compulsory, as you all know. Section B has 2 parts, 1 and 2, each with 2 option items, and you are supposed to respond to only 2 items from section B, where you are supposed to choose 1 item from each of the parts 1 and 2. In total, you are supposed to respond to 3 items, and as you know, any additional items responded to will not be sequenced. So you are supposed to begin each item on a fresh page. All necessary working must be provided. All necessary working must be shown clearly. So the graph paper is provided, and of course silent, non-programmable scientific calculators and mathematical tables with a list of formulae may be used. We shall therefore come to item 1. So item 1, this item comes from section A, and as we have already said in our previous videos, this section is from the construct that we call geometry. You must be aware of all the topics that are tested under this section. We have already discussed about that in our previous videos, that is specifically the structure of mathematics paper for A-Level. If you have not watched that video, check within the description. I will put the link to that video, or else go to TV Math, search for that video about the structure of A-Level mathematics paper. We shall look at the item. It says, an extension worker mapped a village demonstration farm on the Cartesian coordinates in 3 dimensions. He installed a sprinkler at S, which is given as 1 at 3, 2, inside a greenhouse. The greenhouse roof is at the plane 3x minus y plus 2z is equal to 7. A water pipe which runs along the line, this line, enters the greenhouse roof at a point P. The extension worker wishes to move the sprinkler closer if the distance between S and P is more than 5 meters. 2 boundaries of the sprinkler spray zone on the greenhouse floor have equations y is equal to that and 3x plus 4y is equal to 8. The extension worker wishes to change the nozzle if the angle between the 2 spray boundaries is less than 50 degrees. During calibration, the sprinkler rotates through angle x, which satisfies the equation 2 sin x plus 5 cos x minus 1 is equal to 0 for values of x from 0 to 180 degrees inclusive. If the angle is less than 100 degrees, the sprinkler will be adjusted. A faulty nozzle sprays water such that it hits the floor at a point Q, whose distance from the point A is twice its distance from the point B. The extension worker wishes to relocate a plant at 7 if water cannot reach it. Based on mathematical computations, advise the extension worker on the decisions to take. We shall now come to the responses. So this is the response to that. These responses have been prepared by TV Math, and if you are here for the first time, we have an A-Level Mathematics community group, and if you want to be part of that group, please make sure you join using the link in the description. The group is almost getting full, so please make sure you enter as early as possible. So we have our item as that. We shall look at the required response. So for the required response, we shall first of all look at the given different parts. So we have this part here. This is the first part. This is the first part, or what we call the part 1. So it is always important to identify some of these parts such that now it becomes easier to answer that item. So they are saying we shall first of all deal with this part. An extension worker mapped a village demonstration farm on the Cartesian. So he installed a sprinkler at this point inside the house, inside a greenhouse. The greenhouse roof is this. This is the roof of the greenhouse. A water pipe which runs along the line. So the water pipe runs along this, enters the greenhouse roof at a point P. So it enters at a point P. The extension worker wishes to move the sprinkler closer if the distance between S and P. So the distance between S and P is 5 meters. So in other words, we need to look at the distance between S and P, and that distance will help us now to determine whether the extension worker should move the sprinkler closer or not. So let us look at how best we can respond to that. So we are given a 3x minus y plus 2z equaling to 7 as the equation of the plane. And the line is given by this. So this is the line, and this is the line, and this is the plane that we are given. Now, what we need is to find the point P, and of course, where this point P meets the plane, and after we get the distance. So we shall first of all get to know the point P, because we need to obtain the distance. We need to obtain the distance between S and P. So we must first of all know what P is. So we need to first find the point P, and that is the point where the line meets the plane, because they are telling us that a water pipe which runs along the line this enters the greenhouse roof, and the greenhouse roof is given by this. So it enters the greenhouse roof at a point P. So that is the point of intersection between the line and the plane. So that point is the point that we are talking about as the point P. So we shall first of all know the point P, then after we can easily get what we call the distance between S and P. Okay, so let us see how best we can do that. A point P lies on a plane if its coordinates satisfies the plane equation. So you need to recall that a given point lies on a plane if its coordinates satisfies the plane equation. So what we shall be doing is we shall be substituting the point that is x, y, and z into the equation of the plane, because we need the point of intersection between this and this. So we are looking at a point which is the point of intersection between the two. So that point, if it is described by x, y, and z, that point should be able to satisfy this given equation. So where there is x in the equation of the plane, we shall put this. Where there is y, we shall put this. Where there is z, we shall put this one here. So doing that, we should be able to obtain. We should be able to obtain this. So where there is x, we are substituting the x, and where there is y, we are putting the y in the equation of the plane, and where there is z, we are putting 1 minus 2 mu. So all these x, y, and z are obtained from this given equation of the line. So because we know the equation of the line is given by 2 plus mu I, then plus negative 1 plus 2 mu into j, then plus 1 minus 2 mu into k. So this is the equation of the line, and the equation of the plane is given as 3x minus y plus 2z, which is equal to 7. So what does this one imply? We are saying at the point of intersection between this and this. So this one here will be representing our x, and this is representing our y, and this is representing the z component. So that's why we are substituting them here. So substitute them and simplify. So this will be 6, this will be 3, this will be plus 1 minus 2 mu plus 2 minus 4 mu, which is equal to 7. So this and this and this is 3 mu, that will be mu, that will be negative 3 mu. So that is 6 plus 2, that is 8, plus 1, that is 9. So you'll be able to get your mu as 2 over 3. So substitute mu into the line equations, that is for x, y, and z. Remember, our x is represented by 2 plus mu, our y is represented by negative 1 plus 2 mu, our z is represented by 1 minus 2 mu. So substitute for mu equaling to 2 out of 3 into this, this, and that. And when you do that, you'll be able to get 8 over 3, 1 over 3, negative 1 over 3. So that will imply the point of intersection between the line and the plane will be 8 over 3, 1 over 3, negative 1 over 3. So that point of intersection is the point P. So what does that one mean? It means that the water pipe enters the greenhouse roof at the point P, which is given by this, and that will be the entry point. But now we need the distance between the sprinkler and the entry point. We need the distance because they are saying that the extension worker wishes to move the sprinkler closer if the distance between S is where the sprinkler is, and P is the entry point. So we need the distance between the two. So it means we need the distance between S and P. So given that our S is 132, our P is what we have obtained, we need to determine whether the distance exceeds 5 meters. So we shall recall that from the distance formula in 3 dimensions, the distance between any 2 points, if you have x1, y1, z1, and you have x2, y2, and z2, then you can easily get the distance by using this method or the formula. So using this, we shall now be able to get the distance between SC and P. So that will be, so your S, this one can be like our, this one here can be like our x2. So this can be like our x1, y1, and z1. This will be our x2, y2, and z2. So looking at these two, then substitute them into this formula here, then you should be able to get this. Simplify, and when you simplify that, you will be able to get D as 3.92. So getting that, when you are able to get that, then we need to interpret the result. So they are saying that the distance between the sprinkler and the roof entry point is about 3.9. So whenever you are giving your answer, it is always important that you give your answer to 4 decimal places. So it is better to have this as 3.911578. So instead of this, let us maintain this. So the distance between the sprinkler and the roof entry point is about 3.91578 meters. Let us maintain the 4 and above decimal places. Okay, so it will be that. And what does that one mean by the condition that we are given? We are told that the extension worker wishes to move the sprinkler closer if the distance between S and P is more than 5. So when you look at that, the distance that we have, which is 3.91578 meters, this is less than 5 meters, and that means that the sprinkler should not be moved, because the sprinkler will only be moved if the distance between S and P is more than 5. So since the distance is not more than 5, then the sprinkler should not be moved. So that should be your conclusion. So that would be our first part. And our first part, as we have seen, it included 2 parts. That is getting the point P and also getting the distance between S and P. Next, we shall look at the next part. It says 2 boundaries of the sprinkler spray zone on the greenhouse floor have equations. We have this equation and this. The extension worker wishes to change the nozzle if the angle between the 2 spray boundaries is less than 50 degrees. Looking at the information given, we have the boundaries of the sprinkler spray zone. So using that, we need to obtain the angle between those boundaries. So let us look at the given information. The spray boundaries are, we have this one and this. And what do we need? We need to determine whether the nozzle should be changed. And under what conditions will the nozzle be changed if the angle between the 2 boundaries is less than 50 degrees. So we need to get the angle between the 2 boundaries, and that will be done by simply looking at the gradients first. So we shall be using the gradients for the 2 lines to obtain the angle between those boundaries. So from this, y equaling to 2x minus 1, you should be able to realize that this is already in the form of y is equal to mx plus c. So giving us our first gradient as 2. And then from this, you need to first rearrange it and make y the subject. So when you do that, you should be able to get y as negative 3 over 4 of x plus 2. So giving us the gradient as negative 3 over 4. So we need to recall that the angle between 2 lines with slopes m1 and m2 is given by tan theta, which is equal to the magnitude m2 minus m1 over 1 plus m1 times m2. So you have your m1 as this, as 2, you have your m2 as this. So substitute for them, substitute and simplify. So when you simplify this, you should be able to get negative 11 over 4. So you are having this minus 2, get the LCM, which is 4, divide it by 1, that is the negative 8. So 4 divided by 4 is 1. Let us begin by that. Negative 3 minus, that will be 8. So giving us negative 11 over 4. Simplify what you have here. This will be 1 minus 3 over 2. So this should be able to give us 2 minus 3 over 2, and that is negative a half. So you should be able to get this. So divide the 2. You are having negative 11 over 4. Divide it by negative a half. So when you are dividing, you multiply by reciprocal, and this should be able to give us 11 over 2. So you should be able to get that. Now take tan inverse. You have taken the magnitude of this one here. This is still a positive. Magnitude of a positive will remain positive. So take tan inverse of 11 over 2, and that should be able to give us 79.7. Okay, so that should be our answer. So we look at the angle. So the angle between the spray boundaries is approximately 79.7 degrees. But from the given information, you realize that they said the extension worker wishes to change the nozzle if the angle between the two spray boundaries is less than 50 degrees. So the angle that we have obtained is actually more than 50 degrees. So what does that one mean? They are saying wishes to change if the angle between them is less than, but the angle we have obtained is greater than. So it means the nozzle should not be changed. That should be the conclusion. So please make sure you don't forget the conclusion. It's very important. So that is basically our, this is basically our part 2. So this is our part 2. And now we want to look at this, and this will be our part 3. So they are saying during calibration, the sprinkler rotates through angle x, which satisfies the equation 2 sine of x plus 5 cos x minus 1 is equal to 0 for the values of x in this range. If the angle is less than 100 degrees, the sprinkler will be adjusted. So looking at the given information, we are given that 2 sine x plus 5 cos x minus 1 is equal to 0 for x in this range. So what do we need? We need to determine whether the adjustment is needed, and the adjustment is needed if the angle is less than 100 degrees. So we need to solve this first. So looking at this, you realize that this one here, we can easily apply the R formula. So what we shall do is we shall let 2 sine of x plus 5 cos of x to be equal to 1. So you are having 2 sine x plus 5 cos x is equal to 1. So we shall relate this to be equal to the R sine of x plus alpha. So you must be able to recall the harmonic forms, so or the R formula. So this is sine, so we shall maintain our sign here. If we need the expansion where we shall get a plus, then this must be a plus. So this will be equivalent to R. Expand this. This will be sine of x. This will be cos of alpha, then plus this will be cos x, then sine of alpha. So you can go on and expand this. So that will be R sine of x cos of alpha, then plus R cos of x sine of alpha. So you can have this as R cos alpha into sine of x plus R sine alpha into cos of x. Our interest is to get the value for R and the alpha. So from here you have this is 2 sine of x plus 5 cos of x. Now from this given point, you compare the coefficients, because if this is equal to this, then it implies that the R cos alpha must be equal to the coefficient of sine, which is 2. And the R sine alpha, which is the coefficient of cos, should be equal to 5. So that is what we should have. So from here, from this equation and from this equation, you realize that to get alpha, I consider equation 2 divided by equation 1. And when I do that, I will have tan of alpha, which is equal to 5 over 2. So when I get this divided by this, R will cancel. Sine divided by cos is tan, which is equal to 5 over 2. And that is what we shall have there. So giving us alpha as, so get tan inverse of 5 divided by 2. So that should be able to give you a 68.198. So that will be 2. So that will be 68.2. So you have got the value for alpha. Now get the value for R. So you get equation 1. You get equation 1 squared. Add there equation 2 squared. So when you do that, it means you have R cos of alpha squared. You are adding there R a sine of alpha squared, and this is equal to 2 squared plus 5 squared. So this will be R squared cos squared alpha plus R squared sine squared alpha, which is equal to this is 29. So giving us R squared into, this will give us R squared into cos squared alpha plus sine squared alpha, which is equal to 29. So this will be equal to 1. So R squared will be equal to 29. So giving us the value for R as the square root of 29. So that is what we shall have. Now, having obtained the value for R and we have the value for alpha, then you will substitute them back you will substitute them back. So where there is r, now it will be square root of 29, then sine of x, then plus alpha. Alpha is 68.2 degrees. So when you look at this one now, so where there is the whole of this, you will simply substitute there, this one here. So when you do that, you should be able now to obtain something like this. You should be able to obtain that square root of 29, sine of x plus 68.2 degrees is equal to 1. So when you divide through by this, you'll be able to get this. So from there, it means that sine of x plus 68.2 degrees is equal to 1 over the square root of 29. So from here, it means x plus 68.2 degrees is sine inverse of 1 over square root of 29. So from here, get square root of that. But it is important that when this one changes, it means also your range should change, because you need x plus 68 point that. So it means your range, which will be that, will be same as 0 degrees plus 68.2 degrees less or equal to x plus 68.2 degrees less or equal to 180 plus 68.2 degrees. So it means your range will be 68.2 degrees less or equal to x plus 68.2 degrees less or equal to. So when you get 180 plus 68.2, that should be able to give you 248.2 degrees. So this should be the new range for this one here. So it means here when you come to this, you have x plus 68.2 degrees, then the sine inverse of 1 divided by the square root of 29 should be giving us around 10. This will give us around 10.7 degrees. This is what we shall get. So after getting this one here, you will now come to your quadrants, because that is what you need to locate. So you need to locate where sine is positive. Sine is positive in this quadrant, 10.70, and in this quadrant, 10.7 degrees. So get the required angles. So the required angles will be this. So meaning that x plus 68.2 degrees will be equal to, so remember the range of our x plus 68.2 is this. So the first angle would be 10.7, but is outside the range, so we shall ignore that. So the next angle will be this. So that angle is same as 180 minus 10.7. That angle is 169.3 degrees. It will be this. So what does that mean? That means that we shall get our x as this angle minus this. So we subtract 68.2, and that will give us 101.1 degrees. So this will be the value for x. So that will be the value of x that we shall obtain. Now the interpretation of the result, the calibration angle is approximately 10.1 degrees, and for that case we shall look at the given condition. The condition is that if the angle is less than this, then the spherical will be adjusted. But when we look at this, the angle is actually greater than the given angle, which is 100 degrees. So if the angle is less than this, the spherical will be adjusted, meaning that the spherical should not be adjusted, since the angle we have obtained is actually greater than the given angle. So that will be the conclusion, and that will be about that. Now let us look at this part here. That will be the last part. A faulty nozzle sprays water such that it hits the floor at a point Q, whose distance from the point A is twice its distance from the point P. The extension worker wishes to locate a plant at 7.4 if water cannot reach it. So based on, okay, now we need to look at how best we can answer that. So we need the locus of the faulty nozzle spray. Let us look at the given scenario. We are given point A. We are given point A as this. We are given point B as 5.3. So we have that point as 5.3. We have the point A, which is 2.1. We have the point where we need to test. This is the point that we need to test. Okay. So the condition is that Q is twice as far from A as from B. And what is required? We need to find the locus and determine whether the plant, this one here, can be reached. Now what we shall do first is to recall that if we want the distance between 2 points, for example x, y, and AB, we can easily obtain that by using this. That is x minus a, then y minus b. Of course, we have to be squaring that. So the given condition is that q, the distance from q to a is twice the distance from point q to b. So this is what we are told. The distance from q to a is twice the distance from q to b. So with that, let us look at now how best we can get the locus. So using this definition of the distance, then we shall have QA. QA, it means you are considering Q, which is XY. You are considering point A, which was given as 2, 1. So the distance between the two will be this. Then this is equal to 2, then you get QB. You have Q and B. So the point B is 5, 3. So get the distance between this and this using this. So you'll be able to get that. Now square on both sides, the square root will cancel, but these two will be squared. So this will be squared, the whole of this will be squared, the whole of this will be squared. So the square here will cancel with that, then the square with this will cancel with this. But these two will also be squared because you are squaring everything. Now after removing the square root, you try to simplify. So simplify this, you get this. Simplify this, you get that. Is equal to, this is x minus 5 squared. When you have x minus 5 squared around, this is x squared minus 10x plus 25. So you are multiplying by this 4. So 4x squared minus 40x plus 100. Then y minus 3 squared, that is y squared minus 6y plus 9. You are multiplying by this 4. This 4. So that is 4y squared minus 24y plus 36. So now simplify this. So take everything this side. This will be 4 minus 1, that will be 3x squared. Then 4y squared minus y squared, 3y squared. Then you have minus 40 plus 4 minus 36. Then minus 24 plus 2, that is minus 22. Then bring this one. This is 4, 5. So this is 136 minus 5, 131, which is equal to 0. So when you look at that, that will be the locus of point Q. So this being the locus of point Q, then it means we have got the locus of point Q. Now we need to test this one here. So they are telling us that the extension worker wishes to locate a plant at 7.4 if water cannot reach it. Remember, they are saying a fountain nozzle sprays water such that it hits the floor at a point Q, which is xy. So this point Q, which is xy, it means that is the point which is on the locus of the locus that we have obtained. Now we need to look at look at this 0.74, if water reaches it or not. The water will reach it if that 0.7 and 4 is able to satisfy this given equation. If you want, you can go on and simplify this. Have this as x squared plus y squared minus 12x. This is minus 22 over 3y. Then plus 131 over 3, which is equal to 0. You can go on and simplify that to that. But then test for 7.4. So when you test for 7.4, it means you are putting your x as 7. So you have 7 squared plus 3, that is 4, plus 4 squared minus 12 times z. Minus 12 times z, your x is 7 minus 22 over 3 times 4. Then plus 131 over 3. So look at that, simplify that. So this will be like 49. This will be 49 plus 16 minus, so 12 times 7, that is 84, minus this is 88 over 3 plus 131 over 3. So looking at that, you have 49, you are adding there 16, subtracting 84, you are subtracting 88 over 3, and you are adding there 131 over 3. So that will give you about, this will give you about negative 14 over 3. So when you look at that, this is for a person who has simplified up to here. But if you have left it here, then simplify, you'll be able to get negative 14. That is what you'll be able to obtain. Now, looking at what we need, or what we are told, you realize that we are told that looking at the given condition, a fountain nozzle sprays water such that it hits the floor at this point Q, at this point Q, whose distance from the point A, it hits water such that it hits the floor, sprays water such that it hits the floor at this point. So it means the point that we put here, if the water is to hit the floor, then it must be satisfying this equation. So in other words, we need to test whether the given point satisfies the equation of the locus. And when you look at what we have obtained, this value is not equal to what? Is not equal to 0. So it means the 0.74 does not satisfy the locus equation. It does not satisfy the locus equation. So what does that one mean? It means that the fault nozzle spray cannot reach the plant at 7.4. So the conclusion will be the plant at 7.4 should be relocated. It should be relocated. So that will be the required answer. So that is one way of how you can do that. Though when you have such an equation, here, which is x squared, you have, let's say you have that equation which is x squared. You have this equation x squared plus y squared minus 12x minus 22 over 3y, and then plus 1, that is 131 over 3 equaling to 0. So you realize that when you go on and obtain the center and the radius, so let us go on and deal with the completing squares. So this and this, so can be giving us x minus 6 squared, then this and this, this will give us y minus, so this will be divided by 2, and that will be 22 over 3, 22 over 6, that will actually be 11 over 3 squared. So we shall subtract what we have put here, that is minus 6 squared, that is 36, then minus 11 squared, that is 121 over 9, then plus 131 over 3 equaling to 0. So this means that we shall have x minus 6 squared plus y minus 11 over 3 squared. Then this simplified should be able to give us around, this should be able to give us, let's simplify that. So negative 36 minus 121 over 9, then we are adding the 131 over 3. So this should be able to give us minus 52 over 9, which is equal to 0. So in other words, we shall be able to have x minus 6 squared plus y minus 11 over 3 squared, which is equal to 52 over 9. So we shall have the center as 6 and 11 over 3. We shall have the radius as square root of 52 over square root of 9. That will be 3. So this will be our radius, this will be our center. Now, when you look at this point, which is 7.4, this point here, when you compare, you get the distance of this point from the radius. So when you get that distance from the radius, you will be having something like this. So this is the center. We are getting the distance of this point, that is 7.4 from the center. So that distance will be same as getting 7 minus 4, which is squared, then plus 4 minus 11 over 3 squared. And this value here will be same as, so let me get that, the square root of 1 squared plus 4, we are subtracting, so that is 4 minus 11 over 3, that is also squared, and everything under square root. So let's get that. Okay, so what shall we have there? So it will give us around 1.054, and this value is actually less than the radius when you look at that. So the radius, which is square root of 52 divided by 3, so that radius there is about 2.4037. So you realize that this point is inside. This point is inside the circle. The point is inside the circle, but though it is inside the circle, this point here is not lying on that circle, on the locus of the circle. So it's not lying on the locus of the circle. And looking at what we are told, looking at the information given here, So they are telling us that a fountain nozzle sprays water such that it hits the floor at a point. It means it will only hit the floor at a point which is Q, whose distance from A is twice the distance from B, which means they have not talked about whether it is inside, whether the point lies inside or the point lies outside. So the point must be satisfied by must be satisfying the equation which is formulated by using Q, A, and B. That's when we shall be able to say that the fountain nozzle sprays water such that it hits the floor at that given point. So it will only hit that given point if that point satisfies the equation of the circle. So basically that will be the advice. So looking at what we have from this given information, it shouldn't be confusing you, because it is this statement here is not saying that the water can reach anywhere up to some radius. Though the point is within the circle, then the water will not be able to fall onto that point. It only falls at the point which is along the what? Along this path. So that is a specific locus. So we are given the circle, so the water runs only on points of that circle. It runs only on points of that circle, nowhere else. So that shouldn't confuse you, though the point lies within the circle, but according to the given information, we might not conclude, we shall not conclude that the given point is reachable. So the point is not reachable because it is not satisfying the equation of the locus. And that will be at the end of our item number 1. Let us now look at item number 2. Item 2 comes from section B, part 1. And in this section, you are supposed to choose only one item. For the purpose of this video, we shall be doing all the items. So, item number 2 says, a college administration is planning activities for the annual Academic Excellence and Innovation Week to ensure fairness in allocating study materials, organizing students' awards, and scheduling the official opening ceremony. The administration applies mathematical reasoning. To allocate revision booklets fairly, 25 times the number of booklets given to each student minus the square of the number of booklets given to each student should be at least 144. For fairness, each student must get at least 8 booklets. The administration has selected 8 student leaders, but only 5 of them will receive certificates of excellence. For their plan to continue, the number of possible selections of certificate winners should not exceed 60, and each cash prize should not be more than 120 million. The certificates for the 5th, 4th, 3rd, 2nd, and 1st positions correspond respectively to the first 5 terms in ascending powers of x in the expansion of 4 plus 3x to the power of 7, where x represents shillings 5. The administration wishes to determine the number of possible ways of awarding the certificates while maintaining fairness. On the day of ceremony, 50 invited guests are expected. The first guest arrives at 9:10 a.m. and each subsequent guest arrives at t minutes after the previous one. The guest of honor is the last person to arrive, and 15 minutes later, the ceremony will officially be declared open. The ceremony is to run for 3 hours, 40 minutes, and must end by 5:59 p.m. Tasks: help the administration whether to carry out the planned format of booklet distribution and certificate awarding, and also advise on the arrival time, T, for the individual guests in order for the function to end on time. So that is our item number 2. So to look at item number 2, we shall begin by looking at the different parts. So this item here has been, of course, divided into different parts. So we shall be considering one part at a go. To allocate revision booklets fairly, 25 times the number of booklets given to each student minus the square of the number of booklets given to each student should be at least 144. For fairness, each student must get at least 8 booklets. So we shall begin by looking at that part, and this will be our first part. So let us look at the required solution. So we shall try to interpret the given information. So we shall first of all let the number of booklets, since we are not knowing the number, so we shall let the number of booklets be given to each student be x. So it means, per the given information, 25 times x, the number of booklets, minus the square, that is x squared, should be at least 144. So that is basically what we shall have. 25x minus x squared is greater or equal to 144. Must be at least, so should be greater or equal to 144. And the number of booklets received by each student should be at least 8 booklets. That is 8 and above. Now, that is what is required. So we need to determine the allowable number of booklets per student and advise whether the planned distribution is fair. So that is basically what is required. So let us first look at the this inequality. We solve that to get the value of x, and we check whether that value will be greater or equal to 8. So we shall look at the quadratic equation. So to solve a quadratic inequality, we shall first, of course, try to rearrange this. So we shall have it as negative x squared plus 25x minus 144 is greater or equal to 0. We shall multiply through by negative, and when you multiply through by negative, or you divide through by negative, you multiply through or divide through by negative, you should be able to get this. And remember, whenever you divide through by negative, the inequality sign changes. So that's why we shall have less or equal. So when you reach here, you can try to go on and simplify this. So when you simplify this, you should be able to get x minus 9 into x minus 16, which is less or equal to 0. So we need to get the critical values. So to get the critical values, we equate x minus 9 to 0 and get x equaling to 9. And also x minus 16 to 0, we get x equaling to 16. So you'll be able to get that. So when you get your critical points, you will test for the acceptable region. So test for the acceptable region. So you have your interval. So you will pick out, you have x equaling to 9 and x equaling to 16. So you will test for the region less than 9, the region between 9 and 16, and the region which is greater than 16. So that is the region you will test. So for the region less than 9, we shall test using, for example, 8, and substitute it here. So this one here is same as x minus 9 into x minus 16, the simplified one. Okay, so from this, we shall put 8. So when you put 8, this will be minus, this will be minus, minus times minus will give us a positive. The region between 9 and 16 will be 10. When you put 10 here is a positive, 10 here is a minus, giving us minus times positive. So that will be a minus. So region greater than 16, we can use like 17. When you place it here, 17, this value will be positive, this value will be positive, and finally, the result should give us a positive. So clearly, the inequality, this inequality, you can deal with the simplified inequality. The simplified form, that is x minus 9 into x minus 16 less than or equal to 0. This inequality here takes the region where we have the negative, because it is less or equal to 0. So it should be negative or equal to 0. So for that region where we have negative is this region, that is 9 less than x less than 16. But we need where it will give us 0. So where shall we have 0? That is where we have x equaling to 16 and x equaling to 9 at the critical points themselves. So it means 9, x equaling to 9 will give us 0, x equaling to 16 will give us 0. And for that case, we shall have 9 less than x less than or 9 less than or equal to x less than or equal to 16 as the interval which satisfies. So looking at the given information, we are told that for the fairness, each student must get at least 8 books. So since each student must receive at least 8 books, the final acceptable range will remain this, because you can see that x is still greater than 8, though it is between, it is from 9 up to 16. So what should be our result about? We shall be able to say that each student should receive between 9 and 16 booklets inclusive. So student can receive 9, can receive 10, or 11 up to 16. So our conclusion will be the booklet distribution plan is fair, provided each student receives from 9 up to 16 booklets. And that will be the required response for the part number 1. So we shall look at part 2. Before we look at part 2, please get to know that if you want or you are interested in obtaining A-Level mock papers that have been done, you can join the WhatsApp group, that is the A-Level TV Math community. And this community here is where we normally share with other students different papers. So if you are interested in obtaining different materials, simply come to the channel, and then you go up to the end. There is this WhatsApp group you can join from here. But I will also attach the link in the distribution, the description for this same video. So you can join our WhatsApp channel. You can simply click here. As we have already said, simply come to Google, place there TV Math Hub online tutoring. Place there that word and search. When you search, it will bring you here. At this given point here, simply click in that. Click there, and when you click here, it will be able to bring you to my website. So this is my website where I download, where I upload most of the documents. So when you come here, you can surely check through for all that you need from TV Math Hub. You can as well fill up a free consultation booking, and I will be able to surely give you some time. You can book via WhatsApp. If you need to get to me, you can book a session with me, and there are very many materials you can obtain: A-level materials, O-level materials, university materials, and these are the A-level mock papers that have been done, as many as you can see here. Very many papers so far for mathematics that have been done. So if you are interested in obtaining this, simply come to this channel, and that is my website. So you'll be able to obtain that. But most importantly, come to the community, join our community. That is the WhatsApp channel, the WhatsApp group. You can as well go to the Telegram. This Telegram is also very important because there are also some documents which might not be on the website, but which are on the Telegram. So please join all our social media channels. So if you are interested in one-to-one tutoring, please, you can give me a call, or you can book right now. So simply come to this and book your one-to-one online tutoring. If you are ready to excel in mathematics, then start your journey to academic excellence today with TV Math Hub. We shall be able to look at part 2. So that was part 1. Part 2, the administration has selected 8 student leaders, but only 5 of them will receive certificates of excellence. For their plan to continue, the number of possible selections of certificate winners should not exceed 60, and each cash prize should not be more than 120 millions. So let us look at how best we can get that. So we shall have this as our part number 2. So looking at the required response, so we need to determine the number of possible selections of certificate winners. The certificate winners are 5, but they are choosing from 8 students. So since these winners here have not been ranked, we shall be using what we call the combinations. So to select 5 winners out of the 8 student leader, then we shall obtain the possible selections by using combinations. So the number of ways of selecting R objects from n objects, you need to recall that it is given by n combination R, which can be written as n factorial over R factorial n minus R factorial. So our n is 8, our R is 5. So when you try to put it there, n is 8, so we have 8 factorial, R is 5, 5 factorial, then 8 minus 5 is 3 factorial. So that will give us 56. So it means there are 56 possible selections of certificate winners. And they are saying these possible selections should not exceed 60 for their plan to continue, should not exceed 60. So looking at that, 56 is less than or equal to 60, which means the administration may continue with the planned selection process. So the process should continue because 56 is actually less than 60, and they had said so long as the possible selections are not exceeding 60, then it means the plan should be able to continue. So we shall have that one answered. So since 56 is less than 60, the administration may continue with the planned selection process. Then the next part, they are saying the cash prize should not exceed 120 millions, but they are saying the certificates for the 5th, 4th, 3rd, 2nd, and 1st positions correspond respectively to the first 5 terms in ascending powers of x. Respectively correspond to the first 5 terms in ascending powers of x. in the expansion of this, where X represents shillings 5. Then the administration wishes to determine the number of possible ways of awarding the certificates while maintaining fairness. So let us go on. So the cash prizes range from, we shall be considering the expansion, the first 5 terms of this expansion. So what is required? The required is we need to first find 5 terms in ascending powers of X, then determine the corresponding cash prizes and check whether any prize exceeds shillings 120 millions. So you need to recall that if you have a plus b to the power of n, the general term in binomial expansion is given by n combination r, a to the power of n minus r, b to the power of r. Or else you can simply say that this by binomial theorem, this is same as n combination 0, that is a to the power of n, then b to the power of 0, plus n combination 1, then a to the power of n minus 1, then b to the power of 1, plus n combination 2, a to the power of n minus 2, b squared, and so on. So the general term is given by that. So it means if we have this one here, if we have 4 plus 3x to the power of 7, we have 4 plus 3x to the power of 7, this can be 7 combination 0, then a, that is 4 to the power of 7, then 3x to the power of 0, then plus 7 combination 1, then 4 to the power of 6, then 3x to the power of 1, then 7 combination 2, 4 to the power of 5, then 3x to the power of 2. Then you will have 7 combination 3, 4 to the power of 4, then 3x to the power of 3. Then plus, we need first 5 terms, 1, 2, 3, 4, then the last one, 7 combination 4, 4 to the power 3, then 3x to the power of 4. So these are the first 5 terms. Now, this one here is the general term in this one here in the expansion for this. So you can use this one, or you can use the general expression for the term in the expansion when you are using the binomial theorem. So that is the same thing we have done here. So T1 corresponds to this first term. This is 0. 4 combination 0 is 1. So you remain with 4 to the power of 7, which will give you this value. So T2 is our second term, which is this 7 combination 1, 4 to the power 6, and then 3 x to the power of 1, which will give you this. So simplify that and get that. Then our third term, which is this one here, is this, which you can simplify to get this. The first term is this 7 combination 3, 7 combination 3, 4 to power 4, 3 x to power 3. This is the one. Then plus this one here, which will be this. So these are the first 5 terms in that expansion. So the first 5 terms are these. But remember that x in this expansion here is representing shillings 5. So now, what will be the positions? They said the fifth, the fourth, the second, the third, the second, and the first position correspond respective to the first 5 terms. So meaning the fifth corresponds to the first term, this fourth corresponds to the second, the third corresponds to the third, this corresponds to the fourth, and this corresponds to the fifth. So for that case, that's why when we put the positions now in their respective places, we shall have the first corresponding to the last. That is the fifth term. The second corresponding to the fourth term, like that. So according to what we have here, this is the fifth term, but it corresponds to the first when you come to this one here. The fifth corresponds to the first term. This corresponds to the second term. This corresponds to the third term. This corresponds to the fourth term. This corresponds to the fifth term. Now, when you look at our terms here, this is the fifth term, so it will correspond to the first position, like that. So from there, we shall substitute for x equaling to 5 shillings. So where there is x, place there 5. So this is x, so we have times 5, which is this shillings, x squared, this times 25, that is 5 squared, giving us this shillings. Remember, x represents 5 shillings. So when you substitute where there is x, you put there the 5 shillings, you'll be getting these amounts respectively. So these are the amounts corresponding to the first, the second, the third, the fourth, and the fifth. So now we need to compare. Remember, they said that for their plan to continue, the number of possible selections of certificate winners should not exceed 60, and each cash prize should not be more than 120 million. So you need to compare the cash prizes that we have here, which are these. Then you compare that with the limit, which is 120 million. So let us look at the largest value, the largest amount here. The largest amount here is 113,400,000 shillings. This is the largest amount. So because this is greater than this, which is greater than that. So we need to look at each of these. You realize that each of these are actually less than 120 millions. This is less than 120. This is less than 120. This is less than 120 M. This is less than 120 M. This is less than 120 M. So you realize that all of them are less than the limit, which is 120 M. Even the largest value here is less than the limit, which is 120 million. So we can easily say that all prices are within the allowed limit. So looking at the interpretation of the result, every price is less than shillings 120 million. So what does that one mean? It means the proposed cash prize structure is acceptable. So that will be acceptable, which means they can continue with their plans. Again, they are saying the administration wishes to determine the number of possible ways of awarding the certificates. Now we are awarding here, we were selecting here. When we look at the possible selections here, these selections were selecting the certificate winners from a group of 8. But now here we need to be ranking them, because they are saying that it wishes to determine the number of possible ways of awarding certificates while maintaining fairness. So now at this moment we are awarding, because we are awarding the certificate to the first position, the second, the third, the fourth, and the fifth. So for that case, the number of ways to award the certificates, because the 5 certificates, that is first through the fifth, are awarded to distinct ranked positions, it means order will be mattering. So for that case, the number of ways of assigning the 5 positions to the 8 leaders is by permutation. So permutation, that is n factorial over r factorial. So that is n permutation r. So for that case, we shall have, this is n minus r factorial. So for that case, we shall have 8 permutation 5 as 8 factorial over 8 factorial over. So this will be 8 factorial divided by 8 minus 5 factorial. So which will be 8 factorial divided by 3 factorial. So 8 factorial, get that, then get 3 factorial, and that will be same as this, because this is same as 8 times 7 times 6 times 5 times 4 times 3 factorial divided by 3 factorial. So this and this will cancel. You remain with this, which will give you that value. So from there, we shall be able to get the number of ways of assigning the 5 positions to the 8 readers, and this will be the value. So that will be the number of ways. So after that, this part will also be answered. Now the next part that we shall be looking at is this part here. So they are saying on the day of the ceremony, 50 invited guests are expected. The first guest arrives at 9:10 a.m. and each subsequent guest arrives at 10 minutes after the previous one. The guest of honor is the last person to arrive, and 15 minutes later, the ceremony will officially be declared open. The ceremony is to run for 3 hours, 40 minutes, and must end by 5:59 p.m. So they are saying we need to advise on the arrival time interval T for the individual guests in order for the function to end on time. So this is our last part that we shall be looking at. So as we look at the arrival time interval for the guests, please, for those that are interested in our premium classes, we always have our classes, that is online classes, to discuss different papers. So if you are interested in joining our premium class at a very small affordable price, so please send me your request, send me a message on WhatsApp so I can add you to the premium class. We usually have such classes where we discuss a lot of papers. We look at different mock bodies, and for those that are interested in one-to-one online, we as well do that. So please, there are very many benefits that you will get when you join the premium class. So in case you are interested, simply call or WhatsApp me via any of these contacts. So these are my contacts. They are all on WhatsApp. So if you are interested in joining the premium class for intensive revisions, so please make sure you send me a message via any of these numbers. So we have an intensive Senior 6 Mathematics revision program, and we shall also have a holiday program running for other 3 weeks. So please, if you want to be part of that program, so send me a message via my numbers. So these are basically what you will get when you join the premium class: intensive revision of major mathematics topics, step-by-step examination techniques, discussion of past papers, mock paper analysis, weekly practice exercises, marking guides, continuous feedback, and support on weak areas. So please make sure you join. Please make sure you join our classes so you can be in position to compete very well national wide. So let us look at the arrival time for guests. So let us first of all set up the timeline. Let us first set up the timeline. So they are telling us the first guest arrives at 9:10 a.m. That is what we are told. The first guest arrives, and each subsequent guest arrives 10 minutes after the previous one. Each subsequent guest arrives 10 minutes after the previous one. Now, they are telling us that the guest of honor is the last person to arrive. The guest of honor is the last person to arrive. And remember, there are 50 invited guests. So if there are 50 invited guests, so the guest of honor will be the 50th guest for that matter. So we are saying the 50th guest will be the guest of honor. And that one will arrive at 9:10 a.m. plus 49 T. Remember, each subsequent guest arrives T minutes after the previous one. So it means the 50th, there will be how many intervals to the 50th person? It means we shall have had 49 guests, and they will have taken 49 times T minutes because each guest arrives T minutes after the previous one. So it means the 50th will come after 49 times T minutes. 49 times T minutes. So if the arrival time was 9:10, then it means the guest of honor, the 50th guest, will arrive at 9:10 plus 49 times T minutes. Then the ceremony opens, they are saying, we are saying guest is the last person, and 15 minutes later, the ceremony will officially be declared open. So 15 minutes later, remember now the guest of honor has reached at this time. That is 9:10 plus 49 times T minutes. Then 15 minutes later, after the guest of honor has arrived, the function will be declared open. So it means the ceremony will, again, okay, that is another information. So it means 15, when they say 15 minutes later, so it means the ceremony will open after, that is after 49 T minutes plus 15, because the guest of honor is arriving at this time, but 15 minutes later, that one starts. The function starts. So it means the function will start at 9:10 plus 49 T plus 15 minutes. Again, they are saying that the ceremony will officially be declared open. The ceremony is to run for 3 hours and 40 minutes. 3 hours and 40 minutes. So the ceremony will run for 3 hours and 40 minutes. So 3 hours and 40 minutes, that is same as 3 times 60 plus 40. So this is 180 plus 40, which is 220 minutes. 220 minutes. So the ceremony will run for these minutes. Now the ceremony must end by this time. It means it should end at a time which is less or equal to this one here. It must end at a time which is less or equal to this. Now, the ceremony must end by this time. So let us formulate the inequality. So we shall be working in minutes after midnight. So 9:10 a.m. will be representing 450 minutes. So we are counting the minutes after midnight. So how many hours are there? Then by the time you reach at 9:10 a.m., then how many minutes will be? So from midnight up to 9 a.m., those are 9 hours. So 9 hours. So plus the 10 minutes. So that is from midnight up to 9 a.m. So there will be 9 hours. So 9 hours, that is 9 times 60, then plus 10. So this will give us 9 times that will be 540 plus 10, and that will give us 550. Then what will be the minutes from midnight? Remember, we are working after midnight. From midnight up to 5:59 p.m. So this will be the total number of minutes. So next, we have seen that from midnight up to 5:59, this will be the total minutes. But this is where it comes from. From midnight to 5 p.m., those are 17 hours. Those are 17 hours. So you are getting 17, then 17 times 60. So when you get 17 times 60, that will be 1. This will be 42. So that is 10. So that will be 1020. So you are adding there 59 minutes. So that will be 1079 minutes. So we are working in midnight, minutes from midnight. So it means the first arrival will be this one. That is 9:10 a.m. 9:10 a.m. So the minutes will be that. So this is the last guest delay. The last person will be delayed by these minutes, 49t. And then the opening delay. After the last person reaches, we shall have 15 minutes before the official opening. So these are the 15. These are the 49. From midnight to this is this time. This is the minutes. And then the ceremony will run for 3 and 40 minutes. So this will be 220. So all this, the starting time, the time it will take should not exceed this. Should not exceed this. This is the 5:59 p.m. So looking at that, you simplify it. Simplify this. So you have 550 plus 15 plus that less or equal to 1079. So when you simplify that, so when you get this plus this plus this, you should be able to get 785 plus 49t less or equal to that, which will give us t less or equal to 6. So looking at that, it means that the arrival time must satisfy 0 less than t less or equal to 6 minutes between consecutive guests for the ceremony to open and close on schedule. So that will be the time that will be required to be between the successive or consecutive guests. So that will be at the conclusion. The arrival interval must satisfy 0 less than t less or equal to 6 minutes between consecutive guests for the ceremony to open and close on schedule. So that brings us to the end of item number 2. So that is all about item number 2. And now that will bring us to item number 3. So before we come to item number 3, so if you are interested in getting to us, if you are interested in getting to TV Math, you have any challenges in mathematics, please try to get us via these contacts here. These are the only contacts for TV Math. So if you have or you are given any other contacts other than these, please just know that is a lie. So these are the only contacts for accessing services from TV Math. Don't make any payments, don't make any program with anyone other than a person corresponding to these contacts here, Airtel and MTN. So if you are interested in one-to-one online learning, you are interested in customized examination papers, especially schools, you need papers for O-level mathematics, A-level subsidiary mathematics, A-level mathematics, mock examinations, revision packages and video lessons, university mathematics courses, please contact us via any of these contacts. Looking at item 3, it says the security team was tasked to design a stepped security pillar to be constructed in a sugarcane plantation to monitor and fight fire outbreak. The pillar will provide a high viewpoint for surveillance and quick response. The heights of the steps above the ground increase by the same vertical distance from one step to the next. The height of the 5th step is 3 times the 7th step. The total height of the first 12 steps is 21. The team wishes to redesign the pillar if the total height of the first 5 steps is less than 15 meters. The security, that is safety team, wishes to reduce a response time by placing two communication radios a distance of x in tens of meters from the pillar. One radio shows a signal strength of this and the other shows a signal strength of that. For the safety team to hear clearly without echo, the sum of the two signal strengths must be 8. The safety team wishes to adjust the radios if their distance from the pillar is less than 40 meters. The team wishes to position at least 4 solar powered lights. The main light is positioned at these meters on the plantation grid. The other 3 lights must be positioned at the tube roots of the main light position. The team wishes to relocate the positions of the lights if the sum of the moduli of the positions of these lights is less than 10 meters. Based on mathematical evidence, advise the security team on the decisions to make. We shall look at this as item in different parts. So the first part, we shall be having this, the heights. So the heights of the steps above the ground increase by the same vertical distance from one step to the next. The heights of the 5th step is 3 times the 7th step. The total heights of the first 12 steps is 21 meters. The team wishes to redesign the pillar if the total height of the first 5 steps is less than 15 meters. So we shall look at the required response. So we are looking at item number 3. So the response. Part 1, we shall be looking at the stepped security pillar. So we are given the information that the heights of the steps form an arithmetic progression. So you can easily look at the given scenario. They are saying the heights of this increase by the same vertical distance. So that means you are dealing with arithmetic progression. The heights of the 5th step is 3 times the height of the 7th step. The sum of the first 12 steps is 21. That is the given information. Then the pillar is redesigned if the sum of the first 5 steps is less than 12 meters. That is the given information. So from this information, since we have realized that we are dealing with an AP, then we shall let A to be the height of the first step, and D will be the common difference. And we know that the nth term of an AP is given by A plus n minus 1 into D. Now, since the height of the 5th step is 3 times the height of the 7th step from the given information, then it means that T5 is equal to 3T7. So T is representing the general term. So the 5th term is 3 times the 7th term. But what is the 5th term of an AP, which is given by this? So an AP, so the 5th term will be by substituting where n is by 5. And this will be A plus 4D. That will be A plus 4D. That will be the 5th term. And the 7th term will be A plus 6D. So looking at that, try to simplify that, and you'll be able to get A equaling to negative 7D. Again, we are given the information that the sum of the first 12 steps is 21. So what is sum of an AP? Sum of an AP, sum of n terms of an AP is n divided by 2 into 2A plus n minus 1 into D. So since we are looking at sum of 12 terms, this will be 12 divided by 2 into 2A plus 12 minus 1, 11D. So that is what we shall have here. Now from here, we are given S of 12 as 21. So meaning 21 will be equal to 6 into 2A plus 11D. That is what we shall have. So 21 will be equal to 12A plus 66D. And remember, we are having A equaling to negative 7D. So 21 will be equal to 12 into negative 7D plus 66D. So that will give us a negative 84D plus 66D is equal to 21. And your D will be equal to negative 7 over 6. Because you are having 21, you are having D as 21 over negative 18, which is by 3. This will be 7, this will be 6. So you have negative 7 over 6. So what will be A? Remember, A is a negative 7D, so it will be this times negative 7, and your A will be 49 divided by 6. From what we need, the pillar is redesigned if the sum of the first 5 steps is less than this. So we must look at what will be the sum of the first 5 steps. So as we have seen, for the sum of n terms as n over 2 into 2A plus n minus 1 into D. So you are substituting n as 5. So this is 5 over 2, 2A plus 4D. So you have your A, you have your D. Substitute them. So where there is A, put that. Where there is D, put that. Simplify that, and you'll be able to get 175 divided by 6. So which will be equivalent to approximately 29.1667 meters. Looking at the given condition, the team wishes to redesign the pillar if the total height of the first 5 steps is less than 15. So when you look at what we have got and the given value, which is 15, you realize 29 is greater than this. So the total height of the first 5 steps is not less than 15 meters. So what does that one mean? Then it means the security team should not redesign the pillar, because they said if the total height of this is less than this, they will redesign. If it is less than 15, they will redesign. So it means since it is not less than, then they should not redesign the pillar. Okay, so that is for the first part. That is for the first part. So that would be the conclusion for the first part. So next part, the security team wishes to reduce response time by placing 2 communication radios at a distance of x in tens of meters from the pillar. One radio shows a signal strength of this, and another one shows this one. For the safety team to hear clearly without echo, the sum of the 2 signal strengths must be equal to 8. So when you get this plus this, you should be able to get 8. That is what we are given. So given information is that the radios are placed at a distance of x, which is in tens of meters from the pillar. The first signal strength is this, the second signal strength is this. So the sum of the signal strength is 8. So the given condition is that when I get this, I add there this, I should be able to get 8. So let us try to simplify that to solve for the value of x using that given condition. So from here, 1, we shall realize that here we have x, this is 4, and yet this is a log of 8, and this is x. So we must have one common base. This is x, this is 8. So we shall try to put each of these into a base. The base, which is 2, because 2 is a factor of 8 and 4. So we shall have that. So that is 3 log 8, change the base. So introduce log 2. This will be that divided by log 2 of 8. Then plus 6 log of 2 of 4 divided by log of 2 of x. This is equal to 8. So you are changing the base in logarithm. You need to recall that if you have log a of b, this one is same as log a log c of b divided by log c of a. That is change of base in logarithm. So this will be 3 log of 2 of x divided by 8 is same as 2 to the power of 3. This is 6 log of 2. 4 is same as 2 to the power of 2 over log 2 of x, which is equal to 8. So this will give us 3 log 2 of x over, this will be 3, log 2 of 2 is 1. So this is 3 plus this will be here, that is 12 over log 2 of x, which is equal to 8. So that is what you would have. So we want to let, so this and this will cancel. We want to let y to represent log 2 of x. So this will be y plus 12 upon y is equal to 8. So that is basically what we shall have. So from that, it means we shall have this, when you multiply it through by y, this will be y squared plus 12, which is equal to 8y, meaning that y squared minus 8y plus 12 is equal to 0. Solve for y. So that is what we are having here. Y squared minus 8y plus 12 is equal to 0. So solve that, and you'll be able to get y as 2 and y as 6. So from there, remember that y represents log 2 of x, y represents log 2 of x. So if y represents log 2 of x, then it means that log 2 of x is equal to at 2, or log 2 of x is equal to 6. So remove logarithms. You must recall that if you have log a of b equaling to c, then b is a to the power of c, expressing logarithm in terms of indices. So x will be 2 squared, which is actually equal to 4, and x will be 2 to the power 6, which is 64. But remember, the distance is measured in tens of meters. That is the given information. So in tens of meters, it is here, tens of meters. So that means that for x equaling to 4, the distance will be 40 meters. and for x equaling to 64, the distance will be 640 meters. But the given condition is that the safety team wishes to adjust the radius if their distance from the pillar is less than 40 meters. So, first of all, before we confirm, before we use the x equaling to 4 and 64, we must check whether that x satisfies the given equation, especially when you use this one here, which is already simplified. Hope that one satisfies. So if x is equal to 4, this is log 2 of 4 plus 12 divided by log 2 of 4, and what will this one give us? This will be 2, and this will be 12 divided by 2, so that should be equal to 8, which is true. What about when it is 64? Log 2 of 64 plus 12 divided by log 2 of 64. So what will it give? This will be 2 to the power 6, so that will be 6 plus 12 divided by 6, which is 8. So they both satisfy. Okay, so we can go on and give our conclusion. So this will be 40 meters, this will be 640 meters. So the condition says that the team should adjust the radius if the distance is less than 40 meters. Now, as we can see, neither of these distances is less than 40 meters. So it means that the safety team should not adjust the radius, because they said they will adjust the radius if the distance is less than 40. But none of the distances is less than 40. This is not less than 40, this is equal to 40, so it will not satisfy. So none of these distances is less than 40, which means the team should not adjust the radius, because they would adjust if it is less than 40. So that would be the part that will be answered. Next part, they are saying the team wishes to position at least 4 solar powered lights. The main light is positioned at this on the plantation grid. The other 3 lights must be positioned at the tube roots of the main light position. The team wishes to relocate the positions of the lights if the sum of the moduli of the positions of these lights is less than 10 meters. So let us look at that. So we are looking at solar powered lights. Given information is that the main light is positioned at Z equaling to that. So the other 3 lights are positioned at the tube roots of Z. The lights are relocated if the sum of the moduli of the positions of the 3 lights is less than 10 meters. So first of all, what is the modulus of the main position? So the modulus of the main position, this is the main position, negative 8 plus 8 root 3. So the modulus will be negative 8 squared plus 8 root 3 squared, which will give us 16. So the modulus of that will be equal to 16. Now, they are saying we need to look at the other 3 lights are positioned at the tube roots of Z. So we need to look at the tube roots of Z. So according to the given information, we need to obtain the tube roots of the tube roots of the main light position, because that is where the other 3 lights must be positioned. So from what we have obtained so far, we have the modulus. We have the modulus of Z. So after getting the modulus of Z, so this is basically what we have. So we have the modulus of Z, because we are given Z as negative 8 plus 8 root of 3i. So we have got the modulus of Z. The modulus of Z, which we obtain as negative 8 squared plus 8 root of 3, which is also squared. So we have obtained this. We have obtained this as 16. So that is 16. So from there, we need to now obtain the argument if we are to get the roots, the other 3 roots. So for the argument, we need to locate where this one will be. So we have negative 8. Of course, this is the imaginary, and this is the real part. So this is negative 8, and this will be 8 root of 3. So it means we have our argument in this. So this is where we have theta. So it means tan of theta will be equal to, so this will be opposite, will be 8 root of 3, and this one is 8. So theta will be equal to tan inverse of a root of 3. So theta will be equal to, so what will be the value of a theta? So theta will be equal to 60 degrees. theta will be equal to 60 degrees. So our argument, of z is actually equal to, so you need to take this angle that is from here up to this given point. So that will be 120 degrees. And this 120 degrees is same as 120 over 180 pi. So of course this by 6 will give us 2, by 6 will give us 3. So it means our argument of z is actually 2 out of 3 pi. So that will be the argument of z, and we have got the modulus of z. So in terms of polar form, our z will be equal to, remember, z is should be equal to r into cos of the angle, then plus I sine of the angle. This angle here is the argument, so it means we shall have this as 16 into this is cos of the angle. The angle we are having here is 2 over 3 pi. This angle, the angle we are taking is 2 over 3 pi plus I a sine of 2 over 3 pi. So this will be the z in what we call the argument modulus form, or the polar form. Now to find for the tubes, to find for the tube roots, then we shall now obtain. So we shall say we are required to find. We need to find the tube roots. We need to find the tube roots of z. We need to find the tube roots of z such that for complex numbers w, then w to power 3 will be equal to z. So it means w will be actually equal to z to power a third. So these are the tube roots that we are interested in. So for that case, let us obtain these roots. Remember, z is equal to this. Remember, z is equal to that. Then it means wk will be equal to that is r to power a third into cos of theta plus 2 pi k divided by 3, then plus I sine of theta plus 2 pi k divided by 3. So we are substituting, if you recall very well, from De Moivre's theorem. So you must be able to recall that this z to power 1 over n is same as r to power 1 over n into cos of theta plus 2 pi k divided by n plus I sine of theta plus 2 pi k divided by n. You must be able to recall that. So that is the form that we are using here. So for k, since we are looking at tube roots, so k will be equal to 0, to 1, and 2. So those are the ones we shall be substituting for. So for r to power third, our r is the modulus, so it means this will be same as 16 to power a third. So tube root of 16. This is same as 2, then tube root of 2. Because this 16 here can be written as 8 times 2. So this will be tube root of 8 is 2, then tube root of 2. So we can maintain this. So that will be our r. So let us look at how best we can get those roots, because that is where, according to the information given, the main light is positioned on the, the other 3 lights must be positioned at the tube roots of the main light position. So we need to obtain those roots where the other 3 lights will be positioned. Then after, we look at the team wishes to locate the positions of the lights if the sum of the moduli of the positions of these roots is less than 10 meters. So that is basically what we need to find out. So let us look at 4k. Let us begin by looking at 4k equaling to 0. So 4k equaling to 0, we shall have w1. That will be 2, tube root of 2 into, so this will be cos of theta is the angle that we are having, which is 2 over 3 pi. So this will be 2 over 3 pi, and we divide this by 3 because k is 0, then plus I sine of 2 by 3 pi divided by 3. So we shall be able to get W1. So this will give us a 1.9331. That is plus, and then 1.6197 So this will be the first root. And for k equaling to 1, we shall have that will be a W2, that will be the second root, and still it will be 2 root of 3 of 2 into cos. So for this case we shall have theta plus 2 pi k. So our theta is 2 over 3 pi plus 2 pi k. Our k is 1, and we are dividing this by 3. So then plus I sine of 2 over 3 pi plus 2 pi k, k is 1, divided by 3. So this should be able to give us 2 cube root of 2, and then this one here will be into cos. So we simplify this. Let us simplify this one. So this will be 6. So this will give us 6. This will be 8. So this will be by LCM. So this will be 2 over 3 plus 2. So this will be 6 plus 2, that is 8. So that will be 8 divided by 9 pi. And then plus I sine of 8 divided by 9 pi. So that is what we shall have there. So this will give us negative 2.367877 I, and then plus, not I. So then plus this one here will give us 0.861837 I. So that is our W2. So for k equaling to 3, you do the same. W3 will be 2 cube root of 2 into cos of, now this will be 2 over 3 pi plus 2 pi k. So 2 pi k, our k is 2, not 3. Our k is 2, so 2 pi k, that will be 4 pi. We are dividing this by 3, then plus I sine 2 over 3 pi plus 4 pi divided by 3. So that is what we shall have. So this will give us, so we simplify this, this will be 12, 14. So that will be 14 divided by 9. So that is 2 cube root of 3, cube root of 2. Then we shall have this as cos. This is 12. So that will be 14 over 9 pi. And then plus I sine 14 pi divided by 9. So please make sure that your calculator is in radians, otherwise you might get something which is wrong. So from the calculator, we should be able to get this as 0.43757, then minus 2.48156 I. So this is W3. So these are the 3 roots. These are the 3 roots. So we shall have this as the first root. So it means they should be stationed 1 at this given point. So they are saying the other 3 rights must be positioned at the cube roots of the main right position. So it means they should be positioned. At this point, and then at this point, and then at this point. So these are the 3 locations. So the other 3 rights must be positioned. So we shall say the other 3 rights should be positioned at the other 3 rights should be positioned at, so you put there the W1, the W2, and the W3. So you put this one, you put this one, and you put that. So these are the 3 locations. So from there, they are again saying that the team wishes to locate the positions of the rights if the sum of the moduli of the positions of these rights is less than 10. So when you look at what we have done here, you realize that the modulus for this one will be 2 cube root of 2. The modulus for this will remain the same, and the modulus for this will remain the same, which is 2 root 2, 2 cube root of 2. Even if you put this one to your calculator, the cube root of the modulus for this should as well be the cube root of 16, which is 2 cube root of 2. When you try that, for example, when you get 0.43757 squared, you add there 2.48156 squared. Then you take square root of that answer. You should be able to get 2.5198. And when you get the cube root of 16, you realize you'll get the same answer. So it means when you get the modulus for this, it will be the same modulus for this, it will be the same modulus for this. They have got the same modulus. So the modulus is still the same, which is this one here. So this one, you'll realize that the modulus will remain the same. Even if you square this one, you get the modulus for each, it will still remain the same. So what we shall do for that case, since the modulus, we shall say that the cube roots have the same modulus. And for that case, it means, since I already know the modulus as the cube root of 16, so I will simply get 3 times the cube root of 16, and I will be able to get that. So it means, the total, when you look at that, the sum of the moduli of these positions will be equal to that. Because we have said that these roots here that we have obtained, W1, W2, and W3, have got the same modulus. So that's why we have simply used this one here, we multiply by 3. Now, having obtained the sum of the moduli of the 3 cube roots, as this one here, now we need to look at what will be required. So they are telling us that the team wishes to position at least 4 solar powered lights. The main light is positioned at this, and the other 3 lights are positioned at the cube roots of the main light position. So the team wishes to locate the positions of the lights if the sum of the moduli of the positions of these lights is less than this. So when you look at this one here, when you look at this statement is a bit ambiguous in that they are here saying that the team wishes to locate the positions of the lights if the sum of the moduli of the positions of these. So these lights should have been corresponding to the other 3 lights. But now, again, since they are saying that the team wishes to position at least, so if we go by this word here, which is at least 4 solar powered lights, then it means we are now going to consider all the 4 lights. One which is positioned at this point, another one, the other 3 are positioned at the cube roots of that. So having obtained this, so what will be the total sum of the moduli of the positions of the all lights? So for all the 4 lights, the total moduli or the sum of moduli is, so we shall get the one for the initial one, that was for Z. So the one for Z was 10 was actually 16. So we shall be able to get the one for Z, which is 16, and then we add there the one for the 3, that is 7.55953 meters. So this will give us about 23.55953 meters. So this will be the sum of moduli of all the 4 lights, because they are telling us that the team wishes to position at least 4 solar powered lights. The position of the main light is this, and the position of the other 3 will be where we have the cube roots, which we have already obtained. So if the team wishes to locate the positions of the lights, if the sum of these lights is less than 10, so we can easily see that the sum we have obtained, is actually greater than 10. So on this sum here, we shall add there the 16. So this value should be greater than 10. So the sum of the moduli is greater than 10, and therefore the security team should not, because they told us that the team wishes to relocate at the positions if the sum is less than, so it should not relocate. Should not relocate the positions of the solar powered lights. So here we had used the one for only 3 because this word here, when you look at this, when they say the team wishes to locate the positions of the lights if the sum of the moduli of the positions of these lights, so these lights should have been corresponding to the other 3 lights. But now when we again use this one here, because they are saying the team wishes to position at least 4 solar powered lights, then it means we shall need to also include the distance or the moduli for this, which is the main light. So for that case, when we use all the 4, then we should be able to get the sum for all the 4 lights to be this, and this value is strictly greater than 10, because you will have 23.55953 meters, which is greater than 10 meters. So this statement here is a bit ambiguous, but this is what we shall go with. So when we look at this, the team wishes to position at least 4 solar powered lights. So when we go by that, then it means we shall also include the main light. But when you are to go with the team wishes to locate the positions of the lights if the sum of the position of these lights is less than. So if they say of these lights, it should have been corresponding to the other 3 lights. So this will be our answer. So the sum of the moduli is greater than 10 meters, and the advice should be not to relocate at the positions of the solar powered lights. Okay, so if the positions of these lights is less than 10 meters, so that is basically what we shall have. So the overall advice, the team should keep the pillar design, maintain the correct radio positions, and relocate, and should not relocate the solar powered lights. So that should be the conclusion. The team wishes to relocate the positions of the lights if the sum of the moduli, so it will be relocated if the sum is less than. But now since the sum is greater, then it means it should not be relocated. So that will be all about this item, and that is all about item number 3. So that will bring us to the next item, and that will be item number 4. So let us look at item number 4. Item 4 comes from part 2 of section B, which is the construct that we call calculus. So item 2 and 3 come from algebra. So now let us look at item number 4. So it says a farmer in Uganda district is establishing a beef cattle project on his land along a river. He is to construct a rectangular paddock along the river, forming one side of the enclosure. Only the remaining 3 sides require fencing. The farmer has 1,120 meters of fencing available. Veterinary guidelines recommend that each bull requires 500 meters squared of grazing space. The farmer stocks the farm at a rate proportional to the square of the number of available bulls. Initially, there are 50 bulls on the farm, and after 8 weeks, there are 75 bulls. The farmer wishes to start selling bulls when the farm is stocked to full capacity. To maintain the pasture throughout the year, an irrigation system is installed. The main irrigation pipe follows this path, where X represents the horizontal distance in meters east of the waste source, and Y is the distance in meters north of the waste of the water source. Engineers are to install inspection gadgets at points where the pipe changes direction, which must be 10 meters apart. Task: determine the maximum number of bulls that can be grazed according to the veterinary guideline. Advise the farmer on when to start the sales. Make a recommendation on the engineer's inspection points. So that is the given information, and we shall look at how best we can respond to this. If you are new to this channel, we highly welcome you, and please consider subscribing to TV Math Hub. Subscribing is completely free of charge, but it helps you to remain updated whenever a new video is uploaded. You can join the TV Math Hub community by joining the WhatsApp channel. You can join the WhatsApp community or else you can join the Telegram community. You can follow us on each of the social media handles, Facebook, X. We are also on TikTok, and most importantly, you can follow us on YouTube. Please make sure you like this video, share it with your friends so everyone is able to benefit. Looking at item 4 says a farmer in Uganda district is establishing a beef cattle project on his land along a river. So our part 1 is here. He is to construct a rectangular paddock along the river, forming one side of the enclosure. Only the remaining 3 sides require fencing, and the farmer has this of the fencing available. Then we are told that the veterinary guardians recommend that each bull requires 500 meters squared of grazing space. The farmer stocks the farm at a rate proportional to the square of the number of available bulls. Okay, so let us start by looking at the given information and how best we can respond to that. So we are looking at item number 4. So we want to look at the maximum number of bulls that can be grazed. And we are given the information that the paddock is rectangular. One side lies along the river and requires no fencing. But the available fencing is this. And each bull requires this. So we want to know the maximum number of bulls so that will occupy this space of land. So which means we must first of all get the maximum area of this land. So what will be the dimensions that will maximize the area of this piece of land? We shall let x to be the width perpendicular to the river, and y to be the length that is parallel to the river. So if you are having a river which is like here, so this is the piece of land. So this part does not require, this part here does not require fencing. But we are letting this part that is perpendicular to be x, and this part that is parallel to the river to be like y. So since only 3 sides are fenced, it means the perimeter for this piece of land, that is the total length that will be fenced, will be x plus y. So that's why we have 2x plus y, and the length that of the available fencing is 1120. So it means when you get this plus this x here, then plus y should be able to give you this available fencing. So that's why we shall have 2x plus y is equal to that. We can make y the subject, and we shall be able to have y as that. So let us look at the area of the paddock. So the area, we are considering a rectangular piece of land, so the area will be length times width, so that is xy. So substituting for y as this, then we shall have our area as this one here. So we are interested in dimensions that maximize this piece of land, so we shall differentiate this, that is the dx, and we equate to 0 for maximum. So when you differentiate this, you will get this one here, and when you equate it to 0, you'll be able to get your x as 280 meters. We shall look at the second derivative to verify whether x equaling 280 will give us a maximum. So when you get the second derivative, when you differentiate this for the second time, you'll be able to get -4, which is less than 0. And for that case, it means x equaling to 280 meters will actually give the maximum area. So looking at that, it means we can now get the corresponding value of y. So you have your y as this one here, so substitute for x, and when you do that, you should be able to get 560 meters. So what will be the maximum area? That will be x times y. So when you do that, you'll be able to get this value. So we need the number of bulls, the maximum number of bulls that will fit. So if each of the bulls require an area of 500 meters squared, then it means the total number of bulls that we shall have in this piece of land will be this divided by this. So that will give us 313.6. So that will mean that we shall take the integer value. So we shall take the integer value of this, because we cannot have a fraction of a bull. So for that case, we shall ignore this. And we cannot also say that we round off this one to be 314, because this one here, we cannot have a 0.6 bull, which will give us a full bull. So what we shall do here, we take the integer value, ignoring whatever is here, whether this is 7, 8, so long as it is not an integer. So the integer value is this, 313, and that will be the number of bulls that will be, let's see, that will be the maximum number of bulls that will be occupying the maximum area of that given space. So they are saying veterinary can recommend that each bull requires over. So the farmer stocks the farm. Okay. So we have seen the total number or the maximum stocking capacity will be for 313 bulls. Next, they are telling us that the farmer stocks the farm at the rate proportional to the square of the number of available bulls. So our part A will be answered. Determine the maximum number of bulls that can be grazed according to the veterinary guidelines. So the maximum number of bulls that can be grazed according to the veterinary guidelines will be 313 bulls. And next they are saying, that the farmer stocks the farm at a rate proportional to the square of the number of available bulls. Initially, there are 50 bulls on the farm, and after 8 weeks, there are 75 bulls. The farmer wishes to start selling bulls when the farm is stocked to full capacity. Okay, so we need to advise the farmer on when to start the sales. Now, looking at that part, when the farmer should start selling the bulls, we are given the information that initially he had 50 bulls. After 8 weeks, the number of bulls were 75. And we are told that the rate of increase is proportional to the square of the number of bulls. But we know that the full capacity will be 313 bulls. That is what we have obtained here. Now, we shall let n to be the number of bulls after t weeks. So it means, since the rate of proportionality, since the rate is proportional to the square of the number of bulls, then it means the n dt will be proportional. The n dt will be proportional to n squared. So if the n dt is proportional to n squared, then separate, before that you have to remove the sign of proportionality and put a constant. This is the rate is the rate of increase, meaning this will be k n squared. This is a positive constant. Now from here, separate the variables, so you will have the n over n squared is equal to kt. Now you can integrate. So on integrating, you are integrating n to the power negative 2 dn, which is equal to k dt. So when you integrate this, this will give you negative 1 over n, which is equal to kt, then plus c. So from here, you can now divide through by negative, and this will give you 1 over n is equal to negative kt minus c. So this is c is a constant, so we shall relate that to be like a. So negative kt plus a. So that is what we shall have here. Initially, that is at t equaling to 0, n was 50. So substitute in this. So this will be 1 over 50 is equal to a, because this will be 0. So you get your a as 1 over 50. So from that, you will then have 1 over n is equal to negative kt plus 1 over 50. So, but now, after 8 weeks, so that is when t is 8, n is 75. So now you have 1 over 75, which is equal to negative 8k plus 1 over 50. So bring this one this side, get 1 over 75 minus 1 over 50 is equal to negative 8k. So when you do that, you should be able to get your k as 1 over 1200. So that will be the value of k. Okay, so with that now, your equation will become 1 over n, which is equal to negative kt, negative 1 over this one here, t, then plus 1 over 50. So this becomes your equation. And of course, when you get the LCM here, like the way we did here, 1 over n will be same as, so the LCM is 1200. So when you get 1200, you divide it by 1200, you will get here negative t, and this will be plus, get 1200 divided by 50. So when you divide that by 50, you will get 24. So that's why we have 1 over n as 24 minus t over this. So when you try to get the reciprocal here, so it means n will be equal to 1200 divided by 24 minus t. So that's why we are saying n of t is equal to that. Now at full capacity, n is equal to 313. So substitute there. Substitute here 313 equaling to 1200 divided by 24 minus t, and simplify that. So when you simplify that, you should be able to get t approximately equal to 20.1661 weeks. So we shall be able to get our t as that. So from there, we shall be able to say that the farm reaches a full grazing capacity after approximately 20.1661 weeks. And for that case, it means the farmer should start selling bulls after about 20.1661 weeks from the initial stocking date, because this will be the time for him to reach the maximum capacity of the bulls to graze on that piece of land, which means he should start selling after a time which is 20.166 weeks from the initial stocking date. So that will be the advice to the farmer. Then part C, make a recommendation on the engineer's inspection points. So they are saying that to maintain the pasture throughout the year, an irrigation system is installed. The main irrigation pipe follows this path. This is the path followed by the irrigation pipe, where x represents the horizontal distance in meters east of the water source, and y is this distance north of the water source. Engineers are to install inspection gadgets at points where the pipe changes direction, which must be 10 meters apart. Okay, so that is what we are given, and we need to make the recommendation on the engineer's inspection points. So let us look at that. So we are looking at the recommendation on the engineer's inspection points, and we are given that the pipe follows this. Inspection gadgets are installed where the pipe changes direction, and inspection points must be at least 10 meters apart. Now, a change in direction occurs at turning point where dy dx is equal to 0. We must note that. Or where the gradient is undefined. So, in other words, we need to look at the given path y equaling to this. We shall differentiate this, and after differentiating this, we get dy dx. So, from y equaling to that, this we shall use the product rule. So, u will be x squared, and v will be 10 minus x to the power of a half. So this gives us du dx as 2x. Differentiate this, get the v dx, and v dx will be a half. Reduce the power by 1, and multiply by the derivative of this, which is negative 1. So this will give us negative a half into 10 minus x to power negative a half. So that will be dv dx. You have du dx. So put in the product rule. The product rule, that will be saying it is v du dx. So this is representing du dx. This is our v. And then here you are having a u, which is x squared dv dx. So dv dx is this. This one here can be written as negative 1 over 2 into 10 minus x to power a half. So that is what we shall have. So you will get that. So simplify this. The LCM will be this. So when you multiply it here, this will be 2 times 2, that will be 4. This will times this into 10 minus x. Then you are subtracting x squared. So that's why we have 40 minus 4x minus x squared. So that is 40 minus. So this is okay, this is 4x. So that will be 40x, then 4x squared. So this will be 40x minus 4x squared minus x squared. So that will be 40x minus 5x squared. And for that case, you can pull out the x, and this is 40 minus 5x. So that's why we have this when you simplify it. So we need where dy dx is equal to 0. So we shall equate this to 0. So we remain with x into 40 minus 5x is equal to 0. So you'll be able to get x equaling to 0 and x equaling to 8. So for that case, these will be like our turning points. So for x equaling to 0, what will be y? Remember that y is x squared, square root of 10 minus x. That is our y, which is here. So when x is equal to 0, y will be equal to 0, and 0, 0 will be your point. For x equaling to 8, y will be equal to that. That is 64 square root of 2, which is about 90.5097. So that will be, so this is 5097. So that will be y. So it means your turning point will be 8 and 64 square root of 2. Next, we can look at x equaling to 10, at x equaling to 10, y is 0. At that point, y will be 0. So it means the derivative is undefined at that given point. So it means the pipe terminates with a vertical tangent. So at x equaling to 0, when you put x equaling to 10, at x equaling to 10, it means you will have dy, of course, dy dx will be undefined there, but for y will be 0. So we are saying this is the terminal point, that is where it ends from. So when we look at our sketch, here, let us look at this sketch. So this is the point 0, 0 that we have. This is our point. This one here is our point, which is 8 and 64 square root of 2. This is the turning point. So this turning point here is actually maximum. So this is a maximum turning point. You can even look at that. You can look at even the nature of this turning point here. You can look at the nature of this turning point by using the sign change. So when you look at this one here, so you have the dy dx, and we are looking at x equaling to 8, and this is to the left, and this is to the right. So what will be dy dx? So you have dy dx as this. This is the dy dx, x. Your dy dx is x into 40 minus 5x over 2 square root of 10 minus x. So when you look at to the left of x equaling to 8, to the left of this, so you can take like x equaling to 7. So x equaling to 7, this is positive. So 5 times 7, this will be positive. This one here, 7, 10 minus, that will be positive. So everything will be positive. So it will be like this. Okay. This is like there. Okay. So here to the left, this will be like this. Then to the right, we can use, to the right of 8, we can use 9. So this will be minus, this will be positive, and this will be a positive. So this will be moving down. So we can see that x equaling to 8 will gives a maximum. Or in other words, 8 and 64 root 2 is a maximum point. Then this point here, which is 0, 0, this is actually the source, because as we were told, they were saying that x represents the horizontal distance in east of the water source, and y is the distance in meters north of the water source. So actually 0, 0 represents the water source. So this is where we have the water source. This is where we have the water source. This is where we have the turning point, and this is where it ends from. This is the terminal point. So this is the terminal point. So this will be our sketch showing. This will be the sketch that will be showing the path that is followed by the irrigation pipe. But again, they are saying that engineers are to install inspection gadgets at points where the pipe changes direction, which must be 10 meters apart. So let us look at that. They are saying engineers are to install inspection gadgets at the points where the pipe changes direction, which must be 10 meters apart. So when you look at this is where it changes direction, because it was coming like this, and at this point here it changes the direction and it starts moving downward. So we need to first of all look at the distance. So when you look at the distances between the inspection points, the first one, that is the distance between the source, that is 0, 0, and this one here. So that distance is approximately equal to that. Then when you go on and look at the distance from here up to where it ends from, that distance is also this, because that is 10, 0, and this one here, this is the point, at the turning point. So we also have distance d2 as this. So from there, what can we conclude? So comparing the required spacing, you realize that the distance from this to this point is this, from this point to that is that. So when you look at both the distances, all these distances here that we are having, all the distances that we have from this point to the point where it changes, that is to the point where the pipe changes direction. So that distance there is actually greater than 10, because these are the distances we have obtained from the point where the pipe changes the direction. So all the distances are actually greater than 10. So what will be the recommendation? Because we need to make recommendation on the engineer's inspection points. So the recommendation is the irrigation pipe, which is this, has a single genuine turning point, which is at this given point, as we have all seen. So this point here. Now, the arc length distances from 0, 0 to the turning point and from the turning point are both approximately 90, because when you look at this, they are approximately 90 to 91 meters, which greatly exceeds the required 10 meter spacing, because the spacing we are told is that from here to there should be 10, but looking at what we have obtained, the spacing is actually surely greater than 10. So consequently, it means a single gadget at the turning point might be insufficient, because if it is a single gadget, it will be insufficient. So to satisfy the design requirement, we are saying that the consecutive inspection gadgets, if they are to be at most 10 meters apart, then the engineer should, one, install one gadget exactly at the turning point, because as we can see, is that the distance from this point here, the distance from 0, 0 to this, to the turning point, and from turning point to this, that is the end point, they are approximately bigger than 10, which is actually the recommended distance. So what we are saying, that if they are to install the gadgets, these gadgets will be insufficient if it is only placed at the turning point. So what we are saying is, to satisfy the design requirement, the consecutive inspection gadgets are at most 10 meters apart. So the engineer should, one, install a gadget exactly at this turning point, but also install additional gadgets every 10 meters along the curve. So which means along this curve here, if they are to put a gadget that is requiring at most 10 meters spacing, it means we shall have about 9, because from here up to there is about 91 meters, and from here to there it is also likewise 90 to 91 meters, meaning about 9 gadgets will be required. So about 9 gadgets will be required on each part. So we are saying install one gadget at exactly the turning point, then install additional gadgets every 10 meters along the curve. That is approximately 9 gadgets on the rising section and 9 gadgets on the falling section. So this arrangement yields a total of roughly 18 to 19 gadgets along the pipe of total length, which is about this, ensuring that the direction change point is monitored and that no gap exceeds the 10 meter limit. So basically that will be the end of item number 4. Let us look at the last item, that is item number 5, which comes from calculus as well, and that is part 2. So before we look at this item here, please make sure you like our video. It takes a lot to make such videos, and if you really like our videos, if our videos are really helping you to get to know something, please give us a like. Don't forget to share our videos, and I would like to inform all of you that we shall have a holiday program which will be starting by 21st of August. So if you really wish to be part of this holiday program, make sure you give me a call or you WhatsApp me on any of these numbers to book your place. Otherwise, when the number reaches, we shall be able to stop with that number. So please make sure you be part of this holiday program. In this program here, which will be an intensive holiday program, will be basically helping you in one, intensive revision of major mathematics topics, step-by-step examination techniques, discussion of past papers, mock paper analysis. We shall have weekly practice exercises, marking guides, continuous feedback, and support in weak areas. So we shall have this program. Please make sure you give me a call or simply send me a message. The fee is a very small fee, which is actually possible for each one of us. So that will be the whole day program. So item 5 says a community irrigation project is constructing a decorative water feature and a storage system for a farm. The side profile of the decorative basin is modeled by this units in meters. The region enclosed by the curve and the x-axis is rotated about the x-axis to form a solid basin whose volume must be at least this. Otherwise, there is a need to redesign that decorative feature. At the same project, workers use a spherical water pot of radius 2.5 meters for processing the water. The pot is filled with water to a depth of this. The water is then powered into a cylindrical container of base radius 6 meters. For the project to be a success, the height of the cylindrical tank must not be greater than 0.5 meters. Task with mathematical justifications, analyze the project. We shall begin by looking at the first part where we are having that a community irrigation project is constructing a decorative water feature and a storage system for a farm. So they are saying the side profile of the decorative basin is modeled by this. The region enclosed by the curve and the x-axis is rotated about the x-axis to form a solid basin whose volume must be at least this. Otherwise, there is a need to redesign that decorative feature. So that is what we shall be having. So let us first look at this part. So this will be our first part. So looking at that, let us see the required response. So part A, we are analyzing the decorative basin. We are given that the side profile of the decorative basin is this, where all dimensions are measured in meters. Then they are telling us that the region enclosed by the curve and the x-axis is rotated about the x-axis to form a solid basin, and the basin must have this volume. Now we are required to determine whether the design satisfies the requirement or not. So what we shall do is to first sketch the profile or the side profile of the basin. So to obtain a suitable sketch, we need to determine some important features of the curve. For example, we need to talk about the x-intercept. So the curve meets the x-intercept where the x-axis where y is equal to 0. So where this is equal to 0, it means x into 4 minus x squared will be equal to 0. So x will be equal to 0 or x will be equal to 4. So substitute in y. Remember y is equal to 0, of course, at this point. So it means your intercepts will be 0, 0 and 4, 0. Next, turning point. We need to differentiate this. Use product rule to differentiate this. So you will have a v du dx, which will be times 1. So then x times du, this is v du dx, which is 1. Then v, that is x, u, that is x, and then times dv dx. So you drop this, that is 2, reduce the power by 1, and multiply by the derivative. So we shall have that. So when you simplify this, you should be able to get that, because here you have 4 minus x out, and this will be 4 minus x remaining here, then negative 2x remaining here. So which will give you 4 minus x into 4 minus 3x. So for dy dx equaling to 0, that is for stationary points, it means this will be equal to 0. And for that case, it means your x will be 4 and your x will be 4. Your x will be 4 divided by 3. So next you need to look at the turning point inside the interval is actually x equaling to 4 divided by 3. Remember, our interval is from 0 to 4. So we are taking the one within the given interval as this one here, as x equaling to 4 over 3. So that is majorly the one that we shall consider. So if x is equal to 4, get the corresponding value of y. Remember, y is x into 4 minus x, which is squared. So substitute for x equaling to 4 over 3 and get y. So y will be equal to this. So this will be our turning point. So the nature of the turning point, you need to go on and differentiate this. You need to go on and differentiate this, because this one here is same as 16. If you simplify it, this is 16 minus 12x minus 4x, and then this one here times that will give us plus. This is negative x and negative, so that will give us plus 3x squared. So this will give us 16 minus 16x plus 3x squared. So this will be dy dx. So the 2y, the x squared, will be same as negative 16 plus 6x. So now for x equaling to 4 divided by 3, this will be same as the 2y, the x squared will be same as negative 16 plus 6 times 4 over 3. So this is 8. So this will give us negative 8, which is less than 0. So x equaling to 4 over 3 is a maximum. So this point here is a maximum point. Is a maximum point. So we shall be having this as our turning point. We have the intercepts, so we shall now sketch. So when we sketch our graph, we shall be able to get this sketch here. So this will be our sketch. This is our intercept here. Of course, there is also an intercept there. Then we have the turning point. The turning point is 4 divided by 3. 4 divided by 3 and 9 point that. So 4 divided by 3, that is about 1.33. So that is about 1.33. So this will be our turning point. So this is where we shall have the turning point. So we shall be able now to join these points. This one joins with that, then comes and ends from here. So it is the interval we are considering is from 0 up to 4. So this will be our sketch. Now after sketching this, we need the required region is bounded by the curve, the x-axis. Okay, so the required region is this one, which is shaded. So this is the required region. This is the one that will be rotated, because they are saying the region enclosed by the curve and the x is rotated about the x-axis to form a solid basin. So this is the area or the region which will be rotated along this axis. This is the x-axis. So this will be rotated along this. So when you do the rotation, so the x-axis will be the axis of rotation. So as you can see from here, when it is rotated, it will be forming a basin-like. So this is the axis of rotation. So along the axis of rotation, we are simply picking a small disk here at 2.0. So this is the small disk, or the disk at x equaling to 2. So this one here will represent a very small change along the x-axis. So now we are saying that the shaded region is that region which is bounded by the curve and the x-axis. And the representative vertical strip is representing a very small change along the x-axis. So indication that the strip rotates about the x-axis to form a disk. And this will be the 3D representative disk. So this is what happens when the rotation occurs. Now we need to obtain the volume. So to determine the volume, we shall use the disk method. That is V is equal to pi. That is from x equaling to 1 to x equaling 2, from x equaling to 0 to x equaling to 4, y squared dx. So this is the disk method that we shall be using. So our y is this, so we need this one squared. So you need to square this. So with this one squared, we shall have this. Now simplify it, simplify this one alone first. It will give you this. And then multiply by x squared, it will give you that. So make sure you simplify this, then integrate, then after integrating, put the limits, and you should be able to get that volume there. So this will be the volume, and this volume is approximately equal to 490.3783 meters cubed. Now, we are told that the region enclosed by the curve and the x-axis is rotated about the x-axis to form a solid basin whose volume must be at least this. Otherwise, there is need to redesign. Now, looking at what we have got, the minimum required volume is this, because they want the volume to be at least this one here, meaning this or more than this. And what we have obtained is this volume, and this volume is greater than this. So it means it satisfies the required capacity. So what does that imply? It implies that the decorative basin has a volume of this which exceeds the required minimum volume, which is this. So therefore, the decorative basin meets the design specification, and there is no need for redesigning. So that will be our first part answered. We look at the next part. They are saying at the same project, workers use a spherical water pot of this radius for processing the water. The pot is filled with water to this depth. It is a spherical water pot of this radius. The water pot is filled with water to this depth. The water is then powered into a cylindrical container of this base radius. For the project to be a success, the height of the cylindrical tank must not be greater than 0.5 meters. Now, we need to analyze that. So what are we given? We are given that the project uses a spherical water pot of this radius. So this is the radius of the spherical water pot. The pot contains water to this depth. The water is emptied into a cylindrical container of this radius. So for the project to be successful, the height of the cylinder should be not exceeding 0.5. So let us look at the required response. So we need to determine the volume of the water in the sphere first. So we are saying since the water occupies a depth of this, and it means it will form a spherical cap. So the volume of a spherical cap is given by this. This is the by formula. So the volume of the spherical cap is given by pi h squared into 3 r minus h into 3. Sometimes it is written as simply pi h squared into this is r minus a third h. So if you find this and you find this, the two mean the same. Now, this is the volume of the spherical cap. So if water is powered to a given height and you are dealing with a sphere, so it is powered into a spherical container to a given height and it has got a radius, then this is how we get the volume. So the radius is 2.5, the height is 3.6. So you will substitute into this formula here, into this formula, and you'll be able to get the V. That is the volume of water in the sphere. So after knowing the volume of the water in the sphere, that same volume is the one that was powered into the cylindrical container. Okay, so we shall have this value here. So when you substitute for 3.6, then you substitute for 2.6, you should be able to get this. So it means when you multiply by pi, you should be able to get this as the volume of the water in the sphere. After getting that, they are saying determine the height of water in the cylinder. The volume of the cylinder, we know volume is pi r squared h. So if this h is representing the height of water in the cylinder, V represents the volume of the cylinder. Remember, this same water is the one that was powered in the cylindrical container, which means we shall have the same V. But now this V will be equal to pi r squared h. So our r is 6, so substitute it, and h will be equal to 0.4680 meters. Now remember they are saying that for the project to be a success, the height of the cylindrical tank must not be greater than 0.5. So the height must not be greater than 0.5. So looking at what we have, the height is this. Now the maximum permitted height is 0.5, and what we have calculated is this. So clearly 0.4680 is less than 0.5, which satisfies the requirement. So clearly we shall say that the water occupies the height of this in the cylindrical container, and since this is less than the maximum allowable height of 0.5, then it means the cylindrical storage system satisfies the project requirement. And that will be at the end of our today's paper. So that will bring us to the end of a Jinja joint mock examination. If you find this video helpful, please don't forget to subscribe to this channel. Don't forget to like and share this video to all your friends. Put in the comment section which mock do you want us to look at, and that will be our next video.